Hello, in this lesson we are solving rational expressions. Our essential question, how do you solve rational equations and monitor for extraneous solutions? Steps to solving a rational equation. First, factor when possible. Then, make sure that the denominator on both sides are the same. Multiply both sides of the equation by the common denominator so that all terms become polynomials instead of rational expressions. Make sure to reject any extraneous solution from the final answer. Example 1. Solve the following equation for x and give evidence that your solutions are correct. Before we can multiply to get rid of the denominator, we need to make sure that our denominators on both sides of our equation are the same. I have x over 2 plus 1/3. The least common multiple of 2 and 3 is 6, so I'm going to multiply x over 2 by 3 for the numerator and denominator, and I'm going to multiply 1/3 by 2 for the numerator and the denominator. When I do that, I get 3x over 6 plus 2 over 6 is equal to 5/6. I can combine the denominator and the numerator to get 3x plus 2 over 6 is equal to 5/6. Multiply both sides of the equation by 6. 6 divided by 6 equals 1, and 6 divided by 6 over here equals 1. So we're left with 3x plus 2 equals 5. Solve for x. We get 3x is equal to 3, x is equal to 1. Check our work by plugging in 1 for x and seeing if that equals 5/6. In order to add the left side of my equation, I need to make sure that my denominators are the same. Least common multiple of 2 and 3 is 6. So I'm going to multiply top and bottom by 3 to get the denominator to be 6 for 1/2. And I'm going to multiply top and bottom by 2 to get 1/3 to have a denominator of 6. And we end up with 3 over 6 plus 2 over 6, checking to see if that's still equal to 5/6. 3/6 plus 2/6 is 5/6. Yes, that's equal to 5/6. So x equals 1 is our solution. Solve the equation 3 over x is equal to 8 over x minus 2. Taking this back to our middle school days, these two sides are proportions, so I can cross multiply to get rid of the rational expression and make it into a polynomial. And I get 3 times the quantity x minus 2 is equal to 8x. Distribute the 3 to get 3x minus 6 equals 8x. Solve for x by subtracting 3x on both sides. Get negative 6 is equal to 5x. X is equal to negative 6/5. In this equation, we have to solve for a. We have 1 divided by a plus 2 plus 1 divided by a minus 2 is equal to 4 divided by a squared minus 4. A squared minus 4, I notice, is the difference of perfect squares, so I can factor into a plus 2, a minus 2. In order to solve the equation, I need to make sure that both sides of my denominators are the same. I notice that my least common multiple for both sides is a plus 2, a minus 2. So I'm going to multiply this rational expression, numerator and denominator, by a minus 2. And I'm going to multiply this rational expression, 1 over a minus 2, by a plus 2. And when I do that, I am left with a minus 2 plus a plus 2 divided by a plus 2 times a minus 2 is equal to 4 divided by a plus 2, a minus 2. Want to make sure that I take into account what a cannot equal, since if I end up with this value in my denominator, it's going to give me a denominator of 0 and this world's going to explode. So in my denominators, I cannot have a equal negative 2, and I cannot have a equal positive 2. So I'm going to make sure I write it down. A cannot equal positive 2, and a cannot equal negative 2. Now, In order to solve, I am going to multiply both sides of my equation by a plus 2, a minus 2, which helps get rid of the denominator and gives us a minus 2 plus a plus 2 is equal to 4. We can solve this equation, combine our like terms. A plus a is 2a. Negative 2 plus 2 add up to 0. So 2a is equal to 4. A is equal to 2. But notice that we just said that a cannot equal 2, because if we put 2 in this equation over here, we're going to end up with 2 minus 2, which is 0, and makes this rational expression invalid. In this case, because a is not allowed to equal 2, we have a no solution because a is not allowed to equal 2. What is an extraneous solution? An invalid solution that may arise when we manipulate a rational expression is called an extraneous solution. An extraneous solution is a value that satisfies a transformed equation but does not satisfy the original equation. Solve the following equation. Remember to check for extraneous solutions. Start by factoring x squared minus 8x plus 12. Two numbers that multiply to a positive 12 and add to a negative 8 are negative 6 and negative 2. Our least common multiple for both sides of the equation has to be x minus 6 times x minus 2. Go to multiply the numerator and the denominator of 1 over x minus 6 by x minus 2, and the numerator and the denominator of x over x minus 2 by x minus 6. Simplify our numerators. Distribute the 1 to get x minus 2. Distribute the x to get x squared minus 6x. Multiply both sides of the equation by the least common multiple, which is x minus 6 times x minus 2. This helps us get rid of the denominator, and we are left with x squared minus 6x plus x minus 2 is equal to 4. Combine our like terms to get x squared minus 5x minus 2 equals 4. To solve the quadratic, I need to make sure that it's equal to 0, so I am going to subtract 4 on both sides to end up with x squared minus 5x minus 6. Factor the equation. Two numbers that multiply to a negative 6 and add to a negative 5 are positive 1 and negative 6. So our solutions for x are x equals negative 1 and x equals 6. Going back to the factored form of my original equation, I notice that my denominator has x minus 2 and x minus 6 in it, which means that if I solve for x, I'm not allowed to have x equals 6 in my denominator, and I'm not allowed to have x equals 2 in my denominator. Having one of these values will make my denominator equal to 0, which then I'm dividing by 0, and that's a no bueno. So x equals 6 is not a solution because it will make my denominator equal to 0, so that's an extraneous solution, and we're left with x equals negative 1, so our solution is x equals negative 1. All right, that's it from me. I'll see you all soon.